If you think about the difference between getting something to work and getting it to work safely, one way to look at it is that getting things to work is all about what it's supposed to do. But getting things safe is really more about things it's not supposed to do that are harmful. One of the things that testers learn is that there are a lot more ways to get things wrong than there are to get things right. Those ways may be numerous, they may not happen often, and they may be really strange. But if enough of them happen often enough, then you have a problem that your system won't be safe. In other words, it's all about the edge cases, the things that are surprises. When you're talking about machine learning, some of the edge cases come from gaps in the training data and unintentional biases that are present in the training data. It's things you didn't realize that were teaching your machine learning system to do odd things it's not supposed to do. In many cases, it's unintentional, often very subtle gaming of the training data, so the machine learning system looks like it learns what you wanted, but it's probably not learning what you expected it to learn. Here's a concrete example. For safety, if you're building an automated vehicle, you want to know, is that thing I'm seeing with my camera a person? Because based on it being a person, there's certain expectations of future motion and certain safety properties you want to observe, such as a keep-away distance. Now here's the catch. Safety needs to know, is that a person? But if you ask the machine learning-based perception system, is that a person? The answer you get, you might think answers that question, but that's not what the machine learning system is going to tell you. It's answering the question, is that thing that I'm seeing with my camera like all the people already in my training data? So machine learning-based system may say, I think that's a person with a 97% probability. But it's not actually telling you if it's a person. It's telling you if it looks like all the other people it knows. The difference between those two questions becomes apparent when you think about people who are not like ordinary people, but who still might show up on a roadway. Now, to have a bit of fun and to prove how good humans are at distinguishing very subtle clues as to what they're seeing, I'm going to show a picture, and I want you, when you see the picture, to say, preferably out loud if you can, what you're looking at. And I'll give you a hint. It's either a person or a bird. So I'm going to show you a picture, and it's either a person or bird, and I want you to say the first thing that you think it is. On the count of 3, 1, 2, 3. Well, there's the picture. A machine learning-based classification system said 99.7% bird and was 99% sure there was no person there. Many people, when they see this, have an answer of bird, no, wait, person, because most of the picture is about being a bird. But then when you look a little closer, you find instead of a bottom beak on the chicken, there's a woman's face, and you realize it's a person in a bird suit. Indeed, there are people in chicken suits that are out on the road, typically selling fried chicken or something like that. But the point here is that machine learning systems can be tricked by things that look pretty much like what they're expecting to see, and they're not very good at noticing subtle differences that completely change the meaning. People, on the other hand, can be initially tricked, but then revisit their result and say, wait a minute, that's not right, because there's something a little bit wrong, and they dig a little deeper and say, oh, wait a minute, I was completely wrong, and they're able to change their answers. Machine learning systems are not very good at that kind of process. In terms of edge cases, the edge cases are surprises. They're things you did not train your system on that are novel. They may correspond to a type of object you already know about, but their presentation, the way it looks or the way it acts, is not as expected, so the machine learning systems will be supremely confident that what they're seeing is, in fact, classified completely wrong. The way to look at this in terms of doing training, doing testing, doing safety is edge cases are the things you didn't think of when you were building and testing your system. They will inevitably happen to you in the real world, and the question is, what's your plan to minimize them, and what's your plan to deal with them when they actually do happen?